Hey, have you ever stopped and wondered, what is gravity? Not in a vague, it pulls things down kind of way, but really, what is it? Because I'll tell you right now, what most of us think we know about gravity, it's completely wrong. And no, I'm not saying Newton or Einstein got it all wrong. Their equations work incredibly well. But these are descriptions of what gravity does, not what it is. And today, I'm diving into one of the wildest ideas out there. What if gravity isn't even a fundamental force at all? What if it's just, wait for it, a byproduct of information? Yeah, let that sink in. Okay, let's take a step back. For most of human history, gravity was just, a thing that existed. People saw things fall. End of story. Then, along came Newton in the 17th century, with his famous law of universal gravitation. Force equals the gravitational constant times the masses of two objects divided by the square of the distance between them. Remember that? G, m1, m2, over r squared. Beautifully simple, right? And it works. For apples, for planets, for pretty much everything we can see. But Newton, genius that he was, didn't explain why gravity worked. He literally called it an occult force. Just think about that for a second. The guy who basically invented classical physics thought gravity was spooky action at a distance. Enter Einstein, 2 centuries later, with general relativity. This is when things got really cool. Einstein described gravity not as a force, but as the curvature of space-time itself. Massive objects like planets or stars bend space-time, and that bending tells other objects how to move. Drop something, and it falls not because it's being pulled, but because it's rolling downhill in this warped space-time. Mind-blowing, right? But here's the kicker. Even Einstein's theory doesn't get to the essence of gravity. It's stunningly accurate. Don't get me wrong. And GPS systems, black hole physics, heck, the bending of light by galaxies, all of it depends on general relativity. But is gravity really just the bending of space-time? Or is that just another layer? Now imagine peeling back the onion even further. What if, and this is where it gets speculative but fascinating, gravity emerges from something even more fundamental? That's the premise behind an idea called emergent gravity. You see, physicists have long suspected that at extremely small scales, space-time itself might not even be smooth but discrete, kind of like pixels on a screen. And here's where information comes in. According to thinkers like Eric Verlinde, gravity might not be a standalone phenomenon, but a consequence of how information is organized in space-time. Think about entropy for a second. Yeah, entropy, the measure of how disordered a system is. If you've ever heard of the second law of thermodynamics, you know entropy tends to increase over time in a closed system. Now apply that idea to black holes. Black holes have something called the Bekenstein-Hawking entropy, which is proportional to the surface area of their event horizons, not their volumes. What this suggests is that the amount of information in a black hole is somehow stored on its boundary. And that's where this whole holographic principle comes in. It's the mind-boggling idea that, in some deep sense, all the information in a three-dimensional space might be encoded on its two-dimensional boundary. Still with me? Okay, let's connect the dots here. Verlinde proposed that gravity could actually result from the changing information associated with entropy on these cosmic boundaries. In other words, gravity isn't fundamental, it's emergent, like temperature. Think about temperature for a moment. It's not a fundamental property of individual gas molecules. It only makes sense when you have, trillions of them bouncing around. Could gravity be similar? An emergent property of all the informational bookkeeping happening at microscopic scales across space-time? Wild, huh? To be clear, this is still deeply speculative. But here's what's crazy. There's potential experimental evidence that might lend some credibility to these ideas. Have you ever heard of MOND, or modified Newtonian dynamics? It's this alternative to dark matter that tries to explain why galaxies rotate the way they do. Normally, galaxy rotation curves don't match what we'd expect from just the visible stars and gas. Now, mainstream physics says, okay, fine, add dark matter, and boom, numbers work. But MOND doesn't rely on dark matter. It tweaks the actual laws of gravity. And guess what? Verlinda's emergent gravity aligns, at least partially, with MOND. So could this mean we've been asking completely wrong questions about gravity for decades? Now, before you throw out Einstein entirely, and trust me, we're not doing that, let's look at the challenges. First off, emergent gravity hasn't yet explained all the observations Einstein's theory can. Second, these ideas are tied up with the quest for a quantum theory of gravity, something that's been elusive for, basically forever. We don't yet know how to reconcile quantum mechanics, which rules the tiny world, with general relativity, which rules the cosmic scale. They just don't play nicely together. And emergent gravity, to many, feels like it's still on shaky ground, conceptually and mathematically. Yet the fact that ideas like this even exist tells us something important. Physicists aren't comfortable just sitting back and saying, we've got it all figured out. They're constantly probing deeper, questioning whether what looks fundamental might actually be just emergent. And if gravity is emergent, the implications are staggering. It would mean the entire universe is governed by even more basic rules that we haven't uncovered yet. Rules that might link space-time, information, and entropy in ways we can hardly imagine. It could revolutionize fields like cosmology, possibly answering questions about the origins of the universe, the nature of black holes, or even dark matter and dark energy. But it also leaves us with profound philosophical questions. If gravity emerges from information, what does that say about the nature of reality itself? Is the universe, in essence, just a grand computation? That's where I'll leave it for today. Now, I'm curious, what's your take? Do you think gravity could be something as abstract and counterintuitive as emergent information? Or do you think this is just another wild goose chase in theoretical physics? Let me know down in the comments. And hey, if you enjoyed this dive into the deep end of science, hit that subscribe button and share this with someone who's equally fascinated by the mysteries of the cosmos. Thanks for tuning into Hyperfocus, where we tackle science without shortcuts, without hype, just pure curiosity. Stay hyper-focused, and don't let gravity keep you down.